So we're going to review the properties of the different quadrilaterals we've learned so far, which are the parallelogram and the subsections of parallelograms, which includes the rectangle, the rhombus, and the square. So a parallelogram is defined as a quadrilateral that has opposite parallel sides, two pairs of parallel sides. So that is the definition. If those are true, you can draw a diagonal which makes two congruent triangles using alternate interior angles, which occur from the parallel lines, giving us two triangles that are congruent using ASA. And once that happens, all of these other properties become true. So the other properties include that the adjacent angles are all supplementary. So if this is 30, this will be 150. This will be 30. This will be 150. So that is another property of a parallelogram. So if this is true, your shape is a parallelogram. Opposite angles are congruent is also true. You would have seen it from the numbers a moment ago, but if this is 30, then this is 30. We don't have to represent that with numbers. If I just told you this were congruent and these were congruent, that's also enough information to determine that this is a parallelogram. Opposite sides are congruent, but you'd need both pairs. When the diagonals intersect and they bisect each other, and the last property is that if you have one pair of sides that are both congruent and parallel, you have a parallelogram. And this is because you can draw a diagonal and you can make two triangles that are congruent, and that'll make the other sides congruent as well, which gives you a property of a parallelogram. So these are the 6 properties of a parallelogram. I will put them on screen again if you need to pause to take any notes for them. All right, now we're going to take a look at a rectangle, which is just defined as a parallelogram. So its definition is a parallelogram that also has a right angle. So it is a parallelogram with a right angle. So this shape on its own is not enough information to conclude that is a rectangle, because it has a right angle, but there's no indication that is a parallelogram. We would need at least one property of a rectangle. So let's say we said the opposite sides were congruent. This is now a rectangle. Let's say we said the opposite angles are congruent. So these are congruent and these are congruent. This is a rectangle because it has a property of a parallelogram and a property of a rectangle. Now the rectangle has several other properties. They are that the diagonals are congruent. The diagonals form two pairs of congruent isosceles triangles, and the 4 half diagonals are congruent. So let's take a look at that. So if we were to draw these diagonals, they are congruent in a rectangle. So that would mean that not only would they bisect each other, because they're the same measurement, all of them would be the same. And that means that the 4 triangles that are made in here are actually isosceles triangles. And because these angles are vertical, these 2 triangles are congruent by SAS. These 2 angles are vertical, making these 2 triangles congruent by SAS. And the other important information by these triangles being isosceles is that means we can find the measure of some of the angles using the base angle theorem and the converse base angle theorem. So if we knew that this angle was 30 degrees, we would also know that this angle is 30 degrees. All right. Another thing that helps you determine if a shape is a rectangle is that it has 4 right angles, which also proves it's a parallelogram. So 4 right angles determines it's also a parallelogram, as well as having a right angle. But one right angle by itself is not enough information. If you only knew that there was one right angle, you could have a generic quadrilateral, you can have a trapezoid, or a kite, all of which can be drawn with a right angle in them. So we need to establish that it's also a parallelogram using some other feature. So what 4 right angles does is it shows that the opposite angles are congruent. So that makes these congruent, and these congruent, which is a property of a parallelogram. So 4 right angles is enough information because it has the property of a parallelogram and a rectangle. And just because we define it as a parallelogram with a right angle doesn't mean you need to show that the opposite sides are parallel and that there's a right angle. You can show that it has one property of a parallelogram and one property of a rectangle. And that's more than enough to indicate that this shape is a rectangle. Let's take a look at the rhombus. A rhombus is defined as a parallelogram. So it is a parallelogram, meaning it has at least one of these properties, and it has one pair of adjacent congruent sides. So this is not enough information to indicate that this is a rhombus because it does not have any of the properties of a parallelogram. We would need to know at the very least that the opposite sides were congruent. So if these were congruent and these are congruent, this is now enough information to conclude it's a parallelogram, as well as enough information to conclude it is a rhombus. Now let's take a look at some of the other properties of a rhombus as well. If you were to draw the diagonals in a rhombus, they are actually perpendicular. That's one of the properties of a rhombus. Now, the diagonals will form four right triangles, and not only are they right triangles, they're actually congruent right triangles. And that's because the diagonals bisect each other, making these diagonals halves the same, and these diagonals halves the same. And we now have four right angles here, which makes four triangles that are congruent by SAS. So there's four congruent right triangles in this diagram. And because these four triangles are congruent, their corresponding angles are congruent. So if these angles are all congruent, that makes this diagonal an angle bisector of this angle at this vertex. It's also an angle bisector of this angle at this vertex. So the diagonal of a rhombus is a angle bisector, and it's not just one of them. They're both actually angle bisectors, because these angles are corresponding, and these angles are corresponding, and the corresponding angles of the congruent triangles are congruent. So this angle gets bisected by this diagonal, and so does this angle. So, in order to prove that you have a rhombus, you need to show that your quadrilateral that you're given has at least one property of a parallelogram, as well as one property of a rhombus. Being told that all four sides are congruent is enough information to conclude you have a rhombus, because you have a pair of consecutive sides being congruent, as well as opposite sides being congruent, which is a property of a parallelogram. If you only know about two sides and nothing else, you could potentially be looking at a kite, which would have one pair of consecutive congruent sides, but is also not a parallelogram. So you need to confirm that you have a parallelogram as well. All right, so I will leave these on screen for a moment if you're going to take any notes on some of the properties of a rhombus, and then we will talk about a square. All right, let's talk about a square. So the definition of a square is it is a parallelogram with a pair of adjacent congruent sides and a right angle. In other words, you need to show that a square is a square by showing it has the property of a parallelogram, a property of a rhombus, and the property of a rectangle. If it has one property of each, it is a square. So there is a unique property to a square, is that the diagonals will actually form four congruent isosceles right triangles, which is actually just a combination of the rectangle property of making isosceles triangles and the rhombus's property of making four congruent right triangles. So this shape we cannot conclude is a square because we do not have the evidence that it is a parallelogram. It has a right angle, meaning it could be a rectangle, but it needs to be a parallelogram in order to be a rectangle. It has a pair of congruent adjacent sides, so it could be a rhombus, but it also might be a kite. So we need to provide additional information. So we need to know either that the opposite sides are congruent, or that the opposite angles are congruent. We need some additional piece of information. All right, and just to show the four congruent isosceles right triangles from before, just do that briefly. If this was a rectangle, a square, all the angles would be right angles and all the sides would be congruent. The diagonals would be perpendicular because that's a property of a rhombus. And the four half diagonals would be congruent because it's a property of a rectangle. And we would then get that all of these triangles are actually congruent by SSS, and they would all be isosceles because of the rectangle property. Now, in order to show that a quadrilateral is a rectangle, you can have four pairs of congruent sides and what you could do to show that you have a square is that it has the properties of, it has four congruent sides and four congruent angles. If it doesn't have all of those, it could be one of the other shapes. So I'm going to leave the properties on screen for now if you need to take those down. You should have obtained most of these properties from the previous slides, and that is it. I will see you in class tomorrow, where we'll continue to review for our quiz on Friday.